Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening near the end of today's webinar is a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is making security more efficient for developers. Our speakers today are Andrew Fife, who is a member of the product team at ShiftLeft, and Vincent Hobson, who is an application engineer at ShiftLeft. Gentlemen, thank you so much for joining me. Really appreciate you being here today.
Yeah, thank you, Charlene. Really appreciate the introduction, and thanks to everyone who's joining us today as well. The topic of making security more efficient for developers is one that we find really exciting because we think that this notion of developer productivity in a security context is really the key to how application security can catch back up to the modern software development lifecycle, which has unfortunately kind of left application security behind. So with that being said, we will jump right in. So last month, actually on June 30th, so just a couple weeks ago, we released a survey that we had been running in April, May, and June. And that survey was about developer productivity and security. And we got a really strong result back from it. 96% of developers report that the disconnect between their own workflows and that of the security team are actually hurting their productivity. So, when it comes to these surveys, you often see a little of this, a little of that, but when you see a signal this strong, you really know that you're on to something. But where is that disconnect coming from? So when you think about the last 20 years or so of innovation in the software development lifecycle and in application security, we'll notice some pretty interesting trends. I'm not going to dive into every single one of these points because I think it's probably a fun trip down memory lane, but something that everybody here is pretty familiar with. Suffice it to say, there's been a lot of innovation in how software gets built and deployed and consumed over the last 20 years. Really big industry changing changes that have happened, kind of almost every 4 or 5 years. And on the flip side, in security, what we see is a cluster of innovation that happened in the early 2000s. So we had OWASP get founded in 2001. That's certainly a significant application security milestone. And then between 2002 and 2003, we saw sort of the modern incarnations of some of our core security technologies, the web application firewall, static code analysis, and then dynamic analysis tools as well. But not a whole lot of innovation until the last couple years when we saw the prevalence of identifying open source CVEs, new ways to test with interactive security testing and bug bounty programs. And the point of this is not to say that security hasn't innovated. These security innovations actually have made an impact, but they're nowhere near the same scale that's happened in the software development lifecycle. So whereas we've seen exponential innovation come in the way in which we build, deliver, and consume software, the way in which we secure that same software has really only seen incremental innovations. So what started as a small fissure, back in the days when we had waterfall development methods and organizations were releasing annually or quarterly, what started as a small gap has become a large innovation gap now. And so we have to start thinking, what does that mean? When you look back and you say, for technologies and processes that were built nearly 20 years ago, how can we modernize them today? And what is the result of this disconnect? So the main innovation that's been driven by all these new technologies is getting software to market much more efficiently through new feature releases. And so in this survey that we ran over the last couple months, one of the key questions that we asked was about release frequency. At the same time, one of the largest application security vendors in the market provides an annual survey of their own customers. And that has very good data on average SaaS scanning. And this is where you'll start to see a pretty big disconnect, because what our survey shows is that 70% of organizations are releasing multiple times per month. But if you look at the way that people are using the market-leading security tools, 82%, the overwhelming majority, are actually scanning less frequently than that. So what this is telling us is that as as the software development lifecycle is getting more efficient, more and more code is being scanned after it's already been released in production. And then another way to sort of check ourselves and say, hey, are we looking at the right things, is to look not just at the averages, but also to look at the leaders. So when you look at the leaders in the software development release process, you've got nearly 20%, nearly the top fifth, that's releasing daily or more. When we compare that to when people are actually running their SaaS scans, we can see that it's significantly below 1%. So we're creating all this innovation in the software development lifecycle is actually creating a challenge that so far security hasn't been able to meet. And that disconnect is, as we saw, 96% of developers are saying causes a pretty significant problem for them. So when we think about the way in which we develop software today, and we think about the way in which we run security, I'm sure that these phases of the software development lifecycle look very, familiar to you. And it's no surprise when we think about security, we're running a SAS scan, and the first step once we get results is to perform triage. And then we take those vulnerabilities and we give them to a development team. So there's two key things to notice here. The first is that this security process is not integrated into the software development lifecycle. It's predominantly happening outside of that lifecycle. The second thing to notice is that after we do the triage of the vulnerabilities, we give them to the development team. We don't give them to the individual developer. So what this means is that we're creating a bunch of issues that don't necessarily need to be there. First and foremost, it's hard to figure out who exactly wrote the code, which exact version, which commit was this in. Second, we're forcing developers into context switches. They wrote the code a long time ago, and it's no longer fresh in their minds. And so that hurts the efficiency of fixing it. And the longer that goes, the more likely it is that some other developer, when they open their own feature branch, wound up pulling vulnerable code out of the master branch, and therefore wrote new code that in some way was dependent on that pre-existing vulnerable code. And that's where a lot of the really significant time-consuming vulnerability fixes come in, because not only do you have to fix the underlying vulnerability, you also have to fix all that tangential code that assumed the code in the master branch was secure. Another thing to think about is when we ran our survey, we noticed that the 4 most common places that organizations are attempting to insert security are also the 4 most common places that developers cite having productivity losses. And when we look at the productivity losses for developers, I think there's a pretty clear trend here. What they're saying is that don't interrupt me while I'm actually writing the code. Let me focus on writing the code. And then you're going to see an inverse relationship between how early and how late you run your security tests. So if you wait until production, you're going to see a lot of loss, and the earlier you do it, the less productivity loss you're going to see. But it's not just our own surveys saying this. IBM ran some of their own analysis, and what they determined is that when you're looking at fixing defects, the earlier you do it in the process can have significant impact on efficiency. And so what IBM is telling us is that, hey, if you can actually address those vulnerabilities in the design phase, you're going to receive a massive benefit in terms of how efficiently you can fix them. And while I certainly wouldn't disagree with that, what I would suggest is that that's a little too philosophical and ivory tower. Yes, when we're talking about the design, it's the excellent place to be looking for business logic flaws. No disagreement there. But in practice, the majority of vulnerabilities are actually from inadvertent mistakes or from a lack of knowledge about secure coding practice. So while in theory, design is the right place to do it, in practice, development is where we need to be focusing on most of our security efforts. And so what I would suggest is rather than worrying about 1x and 6.5x, think about the difference between development and test. This is just simple math here, 15x divided by 6.5x. So what IBM's data is telling us is that if you can fix your vulnerabilities before they go into test, you're going to be a lot more efficient. And if you wait to fix them until they get into production, that's where you're going to see the biggest productivity losses. So the earlier, the better. But what's the solution? Well, so I'd suggest there's 3 different things that we need to think about. The first, and they all basically stem from the fact that most of these tools, their modern incarnate, is almost 20 years old, and so much has changed. So the first thing we need to think about is who's the real user today? Because in the past, all these tools were basically designed for the AppSec team. But what I'd suggest is that the AppSec team isn't always the primary user today, and we'll discuss that in a little more detail. And then the second thing is once we identify who's the real right user, what's a model for efficiency that we can find for their workflows? And how can we sort of redesign those tools? What are the new requirements that we need to think about if we're going to take an existing tool and use it in a different way? So when we think about all the tools that are out there, I would suggest that you think about a spectrum. On the one hand, on the right hand, you've got tools that really are for AppSec professionals. And on the left hand, you've got tools that are really for developers. And of course, there's a mix in between. So if you think about what a WAF or a RASP does, it's attempting to protect the application in real time, or excuse me, in runtime and in real time. And the value that comes from that protection is primarily derived in how the tool is configured and operated. And that configuration and operation happens within the AppSec team. Hence, it's an AppSec-centric tool, and workflows should be designed to optimize the efficiency of the AppSec team. Now, I'm not denying that you can't use a WAF or a RASP as an incredible forensic tool to understand how you can make your application stronger. What I'm saying is that that's not the primary goal of that tool. And so therefore, the design of the user should be for its primary user. Not a groundbreaking concept, but something that we haven't necessarily applied in the same way across all other tools. Because if you think about static application security testing and software composition analysis or open source CVE identification, the value isn't so much in how these tools are configured and automated. It's really what you do with the results once you find them, or said differently, fixing vulnerabilities, which is done by developers, is a heck of a lot more valuable than simply finding them. And of course, there are some tools that sort of sit in between. So when you think about DAST or IAST, yeah, you know, there's a lot of skill that it takes to operate some of the web application scanning tools. And writing good QA tests is the key, really, when it comes to interactive testing. But at the same time, the output are really vulnerabilities for the developers to fix. So there's a bit of both. And so when we're thinking about SAST and IAST, that's really what got us thinking about developer-centric workflows and why they're so important. So a good model, because we think that the Git-based software development lifecycle is pretty efficient, a good model is how developers currently work on unit tests. And so obviously it starts with creating a new feature branch with a commit, and when the individual developer thinks that that code is ready, they'll do a pull request, And then automated in that process is unit testing. And that unit testing, in this example, we're going to say that it doesn't pass. That unit testing gives the developer an immediate analysis of whether or not their changes broke the code. And if their changes broke the code, then they're going to make updates. And only after they've fixed the code will it be accepted into the main branch. So that's a model for which we think there are a number of key learnings for AppSec. First and most important is that developers like it and they use it. There unfortunately is a little bit of tension between security and AppSec, some finger pointing about why do I need to fix this? Is this really real? And we can, and one of the important things here is that developers accept this process. And so if we can mimic something that they like, the much higher chance that we're going to be able to make a lot of progress and fix things without the finger pointing. The second is that it's easy for developers. It all happens within their environment. They get this feedback immediately. They don't have to wait around. And they get the feedback when it's most relevant, right? So imagine if you did unit testing in production or after production. Well, that's a little bit irrelevant because your code might not be working. But at the same time, it'd be so much harder to go back and find the fix, the more time that you let between when you've written the code and when you run these tests. So that context of when you do give the feedback is important. And the feedback is trusted. We don't see large fights between developers and about whether or not the unit test is right. People trust the test. Additionally, the organization is able to enforce standards that are organization-wide that wind up getting applied to the individuals. And there's individual accountability to meet those quality standards. People just know that if they want to get their new feature into the main branch, they're going to have to pass the unit test. There's no argument about it. And then lastly, developers are intelligent people and they're very rational and they like to be efficient. And so what happens is as they start to learn what these standards of quality are, they adapt their own behavior. They adapt their coding processes to meet what the testing standards are telling them. So what exactly does that look like? What I'll do is I'm going to pass the torch over to my colleague Vince, who's going to show you an example of what this can look like for you. All right, Vince, you should have it.
Yes, I do. Okay, thank you, Andrew. This is a demonstration of the power of ShiftLeft in exactly the capacity Andrew explained. From here, what we're looking at are two screens. One screen is GitHub on the left. Our backend system does contain a CI, that's Jenkins. And on the right-hand side, we have ShiftLeft. The developer in general will be developing on a branch exactly in the usual pull request method. They'll develop their code on a branch. Once the branch is complete, they'll then work towards putting that code back into the master by creating a pull request. So let's start by going into the code and creating a pull request. What we're going to do is put in a change inside of the source code that should fail our default policy. And our default policy at this point is simply no new defects. So it doesn't matter what kind of defect it is, simply there will be no defects allowed. So in this case, we're going to edit the file. I'm going to edit the file and plug in a little bit of a problem, a security leak, in fact. And then I'm going to drop this onto a new branch. Now this will allow me to create a pull request that has a number of technical hurdles that have to be overcome. When I create the pull request, I can add additional comments here, and that allows us to tell people if our other people are involved that they need to take a look at what I did and tell them kind of a heads up, here's what happened. Now that I've created the pull request, you can see that we have a number of technical requirements that have to be overcome. Here we have the ShiftLeft, the checkout merge. So we have to check out and merge successfully with the source code from the master, which has already occurred. Our jar file has to be created. This is a Java file. And then we have to be able to perform our analysis. And the analysis says that you can't have any new findings inside of your source code. Now we're comparing it with the master in this case to check to see if there are differences and if those differences cause problems. You can see the first two phases have already completed, the build and the build the jar. Both phases are complete, a relatively small operation. By the way, this software is available from our website if you're interested in taking a look at exactly what the source code is I'm running. If we want to watch the analysis, we can watch it from the ShiftLeft website to see how the analysis is going, or we can also watch it from our development environment. In this case, the developer never needs to leave his environment inside of GitHub in this case, and he doesn't need to go anywhere else to find information. He can simply take a look at the information as it exists here. You'll notice the analysis is fast. It's gone to the second phase already. In general, the analysis for this piece of software takes about 1 minute and 18 seconds or 1 minute and 30. It will generate the output for the entire system. We don't need to run, say, a short scan or a small scan, an incremental scan to take a look at the data. We're actually looking at all of the data presented to the system as a complete operation. Here we can see that we in fact have a failure. Our failure tells us in this case that we have 3 problems inside of the source code, 2 criticals and a moderate. And let's say we want to take a look at the moderate. A convenient link is provided here so that I can simply click there. It takes us into the ShiftLeft area and we can see the data from what this moderate problem is. Inside of the ShiftLeft paradigm, what we've done is we've analyzed the source code from source, which is where attacker controlled data enters the system, to a sink, where the attacker controlled data could cause a problem inside of the system. Now these are adjustable by you. You can introduce your own policies to say that certain sources and sinks are available. But here we're taking a look at a place where the code comes into the system. It's coming into the system via a particular place by the find one. We're going into the database and capturing sensitive information. And then the sink is that sensitive information is being extruded. That extrusion is a string. We'll have to go to the previous so that you can see that it's the line that we modified. So in here, we can see from here, the change we made does introduce a security problem. And the security problem being a moderate problem, maybe we decide that this security problem in particular doesn't need to be addressed. We can address that here inside of the solution. I'll show that a little bit later, or we can address it inside of our environment. So let's return to our GitHub environment. Let's change our policy. So in this case, what we're going to do is we're going to look into the same area for the pull request because we're going to add to this particular problem. We're going to add to this particular branch by going into the patch area. And then from here, we're going to take a look at the ShiftLeft policy file. In this case, the ShiftLeft policy file is saying no new findings. We're not allowing anything to show up. But perhaps we don't really care about that moderate. I'm going to say my ShiftLeft policy should have been no high criticality findings. So what I'm going to do is modify this to allow that. Now what I've done is modified the policy itself to no new high impact defects. This is just a label so you know what rule gets violated. Multiple rules can appear inside of this. It's no problem at all. And you can see that I'm saying that the severity is no high impact findings and a threshold of 0. We could have made this 1, 2, or 3, and it would also allow the entire pull request to go through. But what we're going to do is see simply that the moderate disappears. Now that we've made that change, we're going to commit it back to the same branch. And the way our CI system works is that we'll need to go into the pull request and reissue it. And here, we're going to simply close and reissue the pull request. Now, what that's going to do is reissue the change into the system. The system is going to go through, re-perform the analysis it needs to do to make this work, and represent the findings to you. Note that we do present the findings in nice links that you can use in case you need to pass those about. And those links can be used to perhaps hand information to other people. But in general, the idea is that we want the developer to be able to work inside of this area or whatever area he happens to be in to capture data quickly and to be able to understand what's happening within his source code in a timely fashion. The second analysis is on the way. You can see here that the second analysis has begun. So once again, we've gone through the mechanisms of doing the checkout merge, and we've done the build. So ShiftLeft is looking in this case at the jar file for Java and generating any kinds of findings that we can detect inside of it. Now we report back into the GitHub UI. This allows us to push data back into the developers area so that they can see it without having to switch context perhaps and go into the ShiftLeft UI. They can simply stay here, get a quick cup of coffee, and they're ready to continue their work or perhaps push their data into the master branch. Now the analysis is complete, the CI system reports back to us, and the report comes back that we still have a compliance failure, and that compliance failure is 2 critical findings instead of 3 that we saw before. So with a simple change, we can modify our policy. ShiftLeft allows you to look into the policy to change it to meet your needs as a developer, or you can give the developers access to a policy file that they can use to be sure that their code meets your criterion for merging back into your trunk. And therefore, you've shifted your entire burden of security away from the very back end and test, or maybe at the time of packaging, all the way back to where the developer lives. He didn't have to go anywhere. He got the response in a timely fashion, and now he's able to continue his work by perhaps checking in and making changes inside of here. We could run a third analysis and simply revert our change, but I'm sure you know that that will change. That will simply make it so we can merge the code back. So what does ShiftLeft bring to the party that allows you to have this kind of speed inside of any kind of a reporting tool like this? By looking at the different languages we support, perhaps ones like JavaScript, we have Scala, Java, C#, Go, a number of other languages. Python is coming out very soon. And from there, we're able to scan the code and present information to you in a succinct fashion. If you're looking at the code itself, or if you want to look at the application itself, this is Hello ShiftLeft once again. It's a Java file. In this case, you can see the history of doing all of our analyses. The nice stack chart tells you the different types of findings that we have, as well as the numbers to the right. We do find all of the OWASP top 10, some of the CERT findings and such, and we generally will show you things about those findings, like the entire path. In fact, I'm going to one now that has a longer path so that you can see the long path name, the long path of operations from the source or attacker controlled data tainting to a sink at the very bottom where you have attacker controlled data landing in a sensitive place in your code, which can cause a variety of problems. In this case, we're seeing an HTTP data to HTML via SSN, which is identified inside of the source code as a social security number, and therefore this will be a data extrusion through HTML. Now, looking at the information here is part of the job. The next step is to basically take this information and present it to someone. You would perhaps assign it to someone. It's possible that you can take it and mark these as fixed. And that makes it so that no other engineering effort is required in this particular area. Or you can simply mark it as an ignore. These all allow you the capability of walking every finding inside of ShiftLeft through a life cycle that enhances the developer's ability to work. From here, he can understand where the problem is, what the problem is, and understand what he needs to do. If he's not clear about what the problem is, he can also look into the description and take a look at additional data. This is only a synopsis of information, but he can also take a look at this same problem as referenced from the Common Weakness Enumeration by MITRE.org or the Open Web Application Security Project, and this tells you which of the top 10 that we reference. So these are all important features inside of the tool to help you move forward and work quickly with the system. Those are the big points of ShiftLeft. Our speed, our accuracy, both allow us to work very closely with the developer. He doesn't have to waste time looking at problems that are irrelevant. He doesn't have to waste time looking at problems that don't have any value to him. In fact, working with ShiftLeft to break the build at the appropriate time, which is the pull request, allows him to find problems quickly, modify them, and then move on to something else confident that what he's doing is he's done what he needed to do there, and he can move on to the next step. And that concludes the demonstration of the product itself. Andrew?
All right, thanks. So I will take this back. Okay, so you saw a quick demo, but obviously what we're most proud of is the success that our customers are having with this new model. And so I wanted to share a quote from the VP of Cybersecurity, Thomas Huckeroth at the Emirates Group. These are the folks behind Emirates Airlines. If you're a soccer fan, you probably recognize the Fly Emirates logo that's been on various teams' jerseys. And so what Thomas said is, by scanning every pull request, our software engineers are able to fix vulnerabilities far more efficiently. Not only are we seeing month-over-month decline in MTTR, but it's now common for vulnerabilities to get fixed in the same sprint they are found, and most importantly, our engineers like the process. So we take that validation with tremendous pride because it's exactly what we set out to achieve. But more specifically, wanted to share some data on what our average, what our average customers are seeing with this new approach. And the first thing is there's a massive increase in the SAS scanning frequency that they do. When you're going from ad hoc or insertions later or security insertions later in the process to scanning at every pull request, you're going to expect to see about 110x increase. So what we see in many of our customers is an average of 20 scans per hour that's happening. And the results of that are significant reductions in MTTR. We're not talking about a little bit here, we're talking about a tremendous amount, 5x. The vast majority of vulnerabilities are getting fixed before they go into production. They get fixed within a typical sprint. And 12% of vulnerabilities are even being fixed the same day. Not the same day in which the scan occurs, the same day in which the pull request occurs. That's really different when you think about it, because when you think about the way in which the industry talks about MTTR is about when the vulnerability is identified to the time in which it is fixed. But if you look back at that scanning frequency data, when that vulnerability is identified is not connected in any way to when the code became vulnerable. The code becomes vulnerable when that security flaw is accepted into the master branch. And so by aligning our scans with the pull request, we can now think about MTTR based on when the code is vulnerable. So it's really important to start thinking about that as well, because not only are we reducing MTTR, we're actually raising the bar for what MTTR even means. And then in order to achieve these results, it does require thinking about how we work with SAST a little bit differently. So the first thing is whichever tool you're using, whether it's SAST or whether it's WAF or whether it's DAST, when you start rethinking your security workflows, make sure that you are developing them specifically for that persona that's going to use them. In this case, you want to think about how your developers are actually writing their code, whether it's the model, the Git-based model that we showed, or something else. Your developer experience needs to be designed in as a first principle. And I think a big part of that is making sure that the developers are able to work on vulnerabilities in a process that's familiar to themselves. So don't make them leave their environment. The second thing is speed. So speed is not just the scan time, because there are a couple of other things that can compound it. When it comes to scan time, what I would suggest is you need a tool that can be scanning hundreds of thousands of lines of code in under a minute. But you also need to be thinking about licensing, and you need to be thinking about hardware, because many vendors that are out there are going to charge you more for concurrent licensing. So now think about how that or a hardware bottleneck is going to impact your scanning. If you're talking about, if you're talking about a scan that takes hours, right, and that's what the industry average is, most of them do, and you're not allowed to have concurrent scanning going on, and now you've increased your frequency by 110x to the point that you're scanning 20 times an hour, well, those licensing or those hardware issues are going to create queues. And anytime you start queuing, you're going to really compound those scan times. They're going to quickly go from hours to days or even weeks. So thinking about the licensing and thinking about the extensibility of your hardware. And so really what we're suggesting here is that it's time to really start thinking about the benefits that cloud can offer when it comes to SAST, and really whether or not those outweigh maybe some of the security uncomfortabilities that some organizations still have. That's how you're going to get this flexible hardware that can scale up and scale down depending on the amount of workloads you're throwing at it. And then lastly, equally importantly is the accuracy. Accuracy is important primarily because we got to earn those developers' trust. We know that the average static analysis tool over the last 20 years has had some problems with false positives, and that's what's led to a lot of the finger pointing and the questioning of why certain results are important. So we got to raise the bar when it comes to accuracy, not just to earn the trust of developers, but also to avoid productivity loss. There's nothing worse for productivity than wasting time attempting to fix something only to figure out that it's a false positive. Even the act of the triage is a waste of time. And as a part of that accuracy, as Vince mentioned, data flow is super important. We need to think about attacker controlled data, and we need to think about syncs. And so there may be some routes. All tools are going to have some level of understanding that isn't quite right about your code on day one. So we need to make it really, really easy for developers within the bounds of what security sets for them to be able to teach that tool so that we can take the accuracy to the next level. And once we do that, now here's where the big role for the security team comes back in. You need to have build rules that can enforce your policy standards right there in that pull request. And if you can deliver the speed so developers don't have to wait, and you can deliver the accuracy so that people stop arguing about whether or not the results are real, then you can definitively say, no, if you have a high severity vulnerability in your code, we're not going to accept it into master. And that's where you're going to see some of these really massive benefits when it comes to MTTR. But it's based on the predicate that your developers trust the results and that you can deliver fast, immediate results at the right time. And then, goes without saying, but I think it is worth saying, that if you accomplish all of these, but you reduce the scopes, you're not really advancing the bar. All you're doing is checking a box. So you got to be able to accomplish all of this while still checking for the right vulnerabilities and without cutting corners. And the biggest corner that some people try and cut is by doing incremental scanning. So if you think about vulnerabilities in the relationship with data flow, you can't really get the same level of comprehensiveness if you're only doing an incremental scan. You really need to understand how the new code interacts with the rest of the code base, and that requires a full scan. So that's an important thing to be looking for. Am I able to achieve the speed that I need while doing a full scan? And then second, all tools are created a little bit differently. And most tools do a reasonable job these days of looking for OWASP top 10. But there are other vulnerabilities in the last couple of years that have become more prevalent. One of the most prevalent ones is inadvertent data leaks. And that's something that a lot of tools struggle with. So that's a good thing to have on your checklist too. And then business logic flaws. Well, the reason why data leakage and business logic flaws are a little bit trickier to find and why some tools don't do them is because they tend to be unique to your code base. So for example, when it comes to data leakage, the variable that you determine is sensitive or critical is going to be completely unique to your source code. And so how does a security tool, which is primarily looking for patterns, how is it going to identify a pattern in something that is completely unique to your tool, to your source code? So that's sort of the requirements that we would recommend that you think through as you're starting on your journeys for how you can improve the security efficiency of your development team and the importance of building custom workflows. With that being said, we're sort of at the end of the presentation, and so would love to take everyone's questions and answers. We do have a handful of questions that came in during the presentation, and so we'll start addressing those, but feel free to add anything else in. And I do want to mention, as you can see in large text here, that we do have a free account that you can fire up at any time. It's on-demand self-service. So once you fill out the form to create your account, you will have an instance right away. And it's not a free trial. It's free forever. There are some limitations on how much you can use it in terms of how many hundreds of thousands of lines of code and how many scans per year. But it's a great option to test and learn our process for a larger team or to run fully for a smaller team. So you can see that URL on the screen, but I'm going to send it via chat as well, so you've got a clickable link for anyone who wants to use it. And with that being said, I think we'll jump into the Q&A. All right, give me just 1 second to get reoriented here. Okay, so the first question is, does ShiftLeft complement SAST, DAST, and IAST tools? So yes, ShiftLeft itself is a SAS tool. We offer a static application security testing tool, and that's really what we were walking you through. So we are certainly complementary to DAST and IAST because we ourselves are a SAS tool. How does ShiftLeft handle scalability in an environment where multiple developers work on different pipelines, say a microservices scenario? Vince, you want to answer that?
Absolutely. The microservices scenario generally infers that you'll be doing a lot of concurrent operations, a lot of scans, a lot of concurrent operations. With general SAS tools, one of the things that comes to mind right away is that you have to buy those concurrent operations. With ShiftLeft, that's not done. We operate in the cloud and we're fully scalable from there. So you're able to take information, push it to us, and it feels like you're the only one using the system. So if you have 50 developers, they don't have to wait in a pipeline for their analysis to go through. It goes through immediately when they make the request.
All right, thanks, Vince. So the next question is, how do those workflow operations tie back to the pull request? If I understand the question correctly, the SAS scanning is initiated by the pull request, and then the build rules act as a gate. So the results of the SAS scan are going to determine whether or not that pull request is accepted into the main branch or not. And if it's not accepted, then the developer is given the information that they need to go and fix, and then they attempt to do another, they attempt to merge the code again, and the tests are rerun. And once the code meets the security standard, then it goes back in. So the next question is, are the developers prepared to understand or repair the kind of vulnerabilities the tool may present them, and how the tool gets updates about new vulnerabilities that arise every day? So in terms of developers being prepared to understand and repair the kind of vulnerabilities, what we see is that developers actually want to be responsible for their own code. It's just more historically been a debate about whether or not the quality of the results is real. So once you can get past that accuracy threshold and you can provide the results quickly, we have found that developers buy into this system pretty readily. And in terms of the the updates, Vince, how exactly do we update our tool? I mean, obviously we are running a number of queries, and we expand those queries over time as we see new threats and methods. But what's our update mechanism? That I don't know.
The update mechanism is actually in the cloud. The analysis takes place in the cloud, and we have a code services team that's always watching for these types of things to occur. You don't have to rely on that entirely. You can also write your own policies that will help you find those problems. If there's 0 days and you want to write a policy, you can insert a policy to make sure that that 0 day doesn't affect you.
So the next question is, it takes a couple minutes to run the scan in the branch. What has been the developer's response to this additional step and time in their deploy? I see this as a potential hurdle. So I guess every developer is going to react slightly differently, but the majority of the scans are taking place in under 60 seconds, and we haven't had a lot of pushback on that. Vince, have you experienced much pushback in working with developers on the time that it takes to run the scan?
The developers who have used any other commercial SAS tool look at it as unbelievably fast, and they have no complaint whatsoever. I've only seen the customers that we have that have used things that are, some of our competitors, and those competitors run substantially slower. So they see it as a big benefit.
Okay, the next question, is there an option to have the engine and the dashboard on-prem? Many customers shy away from SaaS platforms for security. So the answer to that is no, but a qualified no. ShiftLeft's next generation static analysis is delivered in the cloud. But the biggest hurdle that most companies have in terms of getting over that is whether or not source code is leaving the premises. And in our case, the answer to that is no. So what we do is we take a representation of the code locally on premise. That representation or metadata winds up being about 15% of the size of the actual source code. And then we communicate that metadata back into our cloud service, and our cloud service then performs the analysis there. The metadata is encrypted with unique keys for each account. It's encrypted in transit, and it's encrypted at rest. ShiftLeft is also SOC 2 Type 2 compliant. And the metadata really is just a bunch of gibberish to anything except our service. So we specifically designed it in a way in which it's, not easily reversible. So what we've found is that the benefits of being in the cloud actually outweigh the potential security concerns when you architect the service in this method. So in other words, if you take a step back and you think about it, there's the trade-off between using an on-prem based tool, which is going to have significant hardware limits and by and large doesn't have the accuracy that you need in order to deliver workflow in this manner, versus doing something in the cloud that is enabling you to reduce your MTTR so dramatically and fix vulnerabilities in the same sprint. When you think about the trade-off that way, achieving the benefits that a cloud-based scanning engine can do for you, I think outweighs the security concerns if you can keep the source code on-prem. Vince, do you have any other take on that?
No, those are the main ones I would also put up. We also encrypt all data at rest. I think that should be said as well. So even if somebody does have the capability of breaking into ShiftLeft, the data that they could receive from us would not only be an abstract version of your code, but it would also be encrypted. And it's a heavy encryption, it's AES. Also, any of the data that they would find, they would also have to try and figure out just what it's telling them, because we don't collect any of your build status, we don't collect any of your code, we don't collect any of the metadata around your system. So we take as little as possible.
Okay, so the next question here is, how does it help minimize false positives? Vince, you want to explain how the CPG is fundamentally different? Excuse me, that is our code property graph.
Yes.
Which we often abbreviate CPG, and it is our core technology. So how is that approach different, and what's the benefit in terms of accuracy, Vince?
The real benefit there is the speed. Most of the people who are looking at the systems have probably an abstract syntax tree. They'll have a call property graph. They'll have a node data graph. They'll have all these different graphs they have to look at, but they'll be put together as individual trees, individual databases. What we've done is taken one of the newer strategies for databases that's come out in the recent years called graph databases, and we're putting our data in that format inside of the product. So when we take your CPG in, we formulate the information in a way that we can search it for a lot of the information we'll need quickly. And that's the main reason for graph databases.
Okay. And it says, is the explanation available in the documents? Can you please point me to it? Yes, we have documentation. You can find links to our documentation in the footer and the header of our website. Next question is, who should be responsible to determine what level of vulnerabilities an application should have? Let's say no errors, or one critical error, or something else. Well, so that's a good question. Ultimately, we at ShiftLeft leave that up to our customers to decide who is going to create that policy. Our approach is to make the policy very easy to implement. As you saw, we've got a YAML file that is inserted into the pull request to form build rules. It's very easy to read. It's very easy for a person to edit. You don't have to get ShiftLeft involved. You can edit it on your own, so it doesn't require creating a support ticket. You can move very quickly. But as a general rule, we think that determining what the policies should be is really still the role of AppSec. But we think that those are policies that should be driven by the AppSec team and whoever is running the AppSec team. And then the next question is ShiftLeft accessing to vulnerability sources real time or regularly? Vince, do you know the answer to that?
It's just regularly. The real-time access to it would require data feed to the NVD or one of the other. There's a whole bunch of them actually that allow you to see incoming vulnerabilities. But what we do is we review them periodically in engineering. So we are aware of them, but we don't have an automated system to grab that information.
Okay, thanks, Vince. And the next question is, what is Ocular versus the SAS product? So this is an interesting question from someone who's been spending some time on our website. So at ShiftLeft, we do have a handful of products. The way to think about Ocular versus the static analysis tool that we just discussed and demoed is that the next generation static analysis is a fully packaged system that is going to run the queries that we have created internally against your source code and present the results in hopefully what you found to be an elegant workflow. When you think about Ocular, it's actually the same scanning engine, and we make the same queries available, but the big difference is that we enable your vulnerability researchers access to the scripting language to be able to write their own queries. So this becomes really important when you start to think about vulnerabilities that are unique to your organization. And the big driver of that is oftentimes business logic flaws. There's no way that a tool on the market without any input from the users is going to be able to understand the unique nature of source code, and all business logic is of course unique. So by applying a vulnerability researcher on your team to use the Ocular tool, you can really dig deep into your code and find all kinds of custom things. It's a very powerful tool. It does take a little bit of a learning curve to get up and running. So the way in which we recommend thinking about it is start with the static code analysis. And then if your organization is the type of organization where you want to do custom research in your own code and you want to dedicate headcount to doing that, then we should have a conversation about Ocular, because it's by far the best tool on the market for that type of searching. So it's kind of, how deep and how custom do you want to go versus are you looking for an elegant method to analyze your code without the custom research. Looks like we got a follow-up question on the frequency of updates. It says, how frequently does ShiftLeft access vulnerability sources? I think that's referring to the question, Vince, about regular versus instantaneous updates.
And I'm not certain offhand exactly how often we do access those sources. I do know that we push out regular updates to the solution itself, and our code team is constantly working on additional features. If you contact us after the meeting, I'd be more than happy to get an answer for you from engineering directly.
And then let's see. Oh, go ahead.
Hi, guys. Sorry, Andrew. I apologize for breaking in here, but we're about 3 minutes to the top of the hour, so I think we're going to have to close out the question and answer period now, and which kind of bums me out because we still have a lot of really great questions. But I do want to let the folks know if we didn't get to your question, if Andrew didn't get to your question, please know that the folks at ShiftLeft will be getting a copy of all the questions that came in, so I'm sure they'll be more than happy to follow up with you offline. Real quick, wanted to remind the audience also that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following the webinar today, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Also at the top of the hour, I didn't mention that we were going to be doing a drawing for 6 $25 Amazon gift cards. So without further ado, why don't we go ahead and do that? Today's winners are Andreas P. Congratulations, Andreas. Albert L. Congratulations, Albert. Craig X. Congratulations, Craig. Joe H. Congratulations, Joe. Stan M. Congratulations, Stan, and Nick S. Congratulations, Nick. We'll be following up with all 6 of you via email after today's webinar about your gift card. So please check your inbox. If you don't see a message there, check your spam folder. Andrew and Vincent, what a great presentation. Thank you so much. Lots of really great content, lots of good information, and I'm sure it's enough to leave the crowd begging for more. So I'm hoping that we'll have lots of conversations about this in the future as well. So thanks again for your time, for your expertise. Really appreciate it.
Yeah, thank you, Charlene. This was fun.
All right, great, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.